Welcome back to my YouTube channel. This is JRF Soil Science class series. Comes under the topic soil texture, and now we can see the part 2 of this lecture. And last lecture we have studied about the soil texture, how we will determine the texture of the soil and to which soil texture class the soil belongs to by using mechanical analysis and the use of soil textural triangle. So uh, we can continue the lecture. Okay, I welcome all you to this lecture series. We can see what are the soil textural groups present. So there are sandy soil, loamy soil, clay soil, and silty soil. And I have already told you, in any soil, say for example sandy soil, only sand is present. That is an incorrect statement, because in sandy soil all the separates are present. Sand, silt, and clay is present, but in different proportion. They show the major property, like property of major uh, soil separate present in it. If in sandy soil, major soil separate present is sand, and the property shown by sand is more than clay and silt. Hence, we will call them as sandy soil. So, in sandy soil, at least 70% sand is present. To call a soil as a sandy soil, there should be at least 70% sand. So, greater than 70% sand should be there. Greater than 70% sand. Here we are focused on sand only because it is sandy soil. Okay. I'm very sorry I can't write like in this. Then when we are coming to the clay content, this is not important, but this is important. 70% sand, at least 70% sand. And it contains less than 15%, less than or equal to 15% clay. So you look, clay percentage is very less, it is less than 15 only, but sand percentage is greater than 70. Hence, we will call them as sandy soil. So if a soil have 70% sand, at least 70% sand, it is sandy soil. Then next, we can say this one, clay soil. Clay soil must contain 35% clay. So if this soil contains 35% clay, like more than 35% clay, like it must contain 35% clay, so it is clay soil. And another condition is that not less than 40% clay, but it must contain 35% clay, not less than. Okay, so this is the range. Hence, we will call them as clay soil. Next is silty soil. Silty soil contain at least 80% silt. Here is 70% sand, but in the case of silt, it is 80%. And clay content is less than or equal to 12%. And coming to the loamy soil. Loamy soil. So this loamy soil contain equal properties of soil separates. We can't say that it contains equal amount of all the soil, but it shows equal property. This property is important. Okay, so loamy soil contain equal properties of all the soil separates, sand, silt, and clay. Then at least 40 to 50% of all soil separates. So at least means greater than 40 to 50% soil separates should be. All soil separates should be present in loamy soil. So just remember the percentage. Sandy soil 70%. Sandy and silty we will say at least, that means more than 70%, and the silty 80%. Clay must contains 35% clay, while loamy soil contains equal properties of all separates. I think everyone understood this slide. Then We will see one by one. Sandy soil. Sandy soil is also known as coarse textured soil. So if we touch this one, we will feel grittiness, like a coarse nature. It is not soft. We can feel that coarseness, is it? So they are loose. Yeah, it's loose. Remember a beach soil? They are loose, right? If we step on that, our chapel will go means very easily. You understood? Okay. So another property is that they absorb water rapidly and drain it quickly. Yeah, it's correct, right? So beach soil, they will absorb that water when the sea wave come. It will absorb water and drain it quickly. We can't say see the water or upside the soil, is it? Then it is well aerated. Aeration is very excellent, and water movement is very excellent. So it can be worked easily in both moist and dry conditions. So they are known as light soil. They are known as light soil because we can use tillage in that soil in both moist and dry condition. Is it? So they are known as light soil. Then it is light textured soil due to lower draft power required to till the soil. So here we will use coarse, and its opposite is fine, fine textured, fine textured. But here we are using light textured. What is its opposite? Opposite of light is heavy, heavy. So I'm very sorry. I'm not that much like I can't write. Okay, so light textured and heavy textured. That is that are opposite. So this sandy soil, because it we can work on that sandy soil by using means low draft power, means that much strength we don't want to spend on for working or by tilling this soil. So they are known as light textured soil because of their easiness to till in this soil. Hmm. Then they have low water and nutrient holding capacity. They are absorb water rapidly and drain it quickly, so they can't hold water, and like that nutrient also they can't hold. Then they have low organic matter content. Then no swelling and shrinkage. They will not swell and shrink. They will while wetting, they will not swell by drying, they will not shrink. So they have no swell shrink property. Then they have poor sealing property of pond and dam. If we use this soil to seal or to make a pond and dam, we can't do that because they have poor sealing property. They are not, they will not form good aggregates on wetting, so we can't use it for this. Okay, then high leaching of nutrients. That's why it has low nutrient holding capacity. And pollutants also leach very fast through the soil. Then fine sand are easily blown by the wind, and coarse sand resist erosion by water. So according to ISSS classification, there are fine sand and coarse sand. What is the diameter of fine sand? It is 2 to 0.2 millimeter, 0.2 millimeter, while coarse sand, sorry, this is coarse sand. Fine sand, how much? 0.2 to 0.2 to 0.02. Okay, okay, then so fine sand with this range of measurement or diameter, they are easily blown by the wind, like they suffer more wind erosion, while coarse sand resist erosion by water erosion. Coarse sand is resistant to water erosion because their particles is much larger in size, so when water comes they will stand like that only. Okay, So I think everyone understood this. So you have to remember sandy soil are coarse textured soil. They absorb water rapidly and drain it quickly. Well aerated, can be worked easily in both moisture and they are known as light soil. Then they have low water and nutrient holding capacity, low organic matter. Then they are susceptible to wind erosion, especially fine sand. They resist water erosion. Which one? Coarse sand. So here it's important. It is light soil because it's not light in weight. Like it is not depending upon the weight. It is why we call light soil. It's easiness for tilling. Depending on that, we will call it this soil as light soil. Okay. The next, loamy soil. So, an ideal loam is a mixture of sand, silt, and clay particles that exhibit the properties of each separates in three equal proportion. So, loam soil contain sand, silt, and clay particles mixture and show all the sand property, silt property, and clay property in equal proportion. So, capacity to retain water and nutrient is better than sandy soil. Sandy soil contain what is a feature of sandy soil? It has low water holding capacity. But since it contains clay and silt, its water holding capacity will be increased. So capacity to retain water and nutrient is better than sandy. It will not compared to sandy. It has good water and nutrient holding capacity. The next drainage and aeration and tillage properties are more favorable than clay soil. So clay soil, what is a feature of clay soil? It will be opposite to sandy soil. That means drainage and aeration are very low, or it is very difficult for the drainage and aeration through clay soil. And tillage property, we can't do tillage easily in clay soil. So because this loam soil contain sand, this property will be increased. That means drainage, aeration, and tillage property. So when compared to clay soil, they have good drainage and aeration and tillage property. However, under certain specific conditions for some specific plant species, sandy or clay soil may be more suitable than a loamy soil. So this suitability of a soil depends upon the plant species under specific condition. Okay, so loam soil is also suitable, but under specific condition for specific plant, sandy or clay soil is more suitable. This is because like when a soil a plant need more water during its growth stages, then what soil will be suitable? Clay soil. If a soil if a plant can't tolerate high water content, like not rice. Rice need water, so rice prefer this clay type of soil. uh, and sandy soil will be favorable for those who need can't tolerate that kind of thing. Is it? Then another important point of ideal loamy soil is that it is ideal soil for crop production. So, which is ideal soil for crop production? It is loamy soil. Then it is gritty and cohesive. It is gritty and cohesive. Then medium textured soil dominating in silt content, medium to water and nutrient holding capacity, moderate aeration, slow to medium air drainage, medium to high organic matter content, moderate leaching of pollutants and nutrients, easily blown by the wind. So up to this, all all the properties are medium because they contain equal properties of all the soil separates. So every property will be medium. Then easily blown by wind and susceptible to water erosion. And this one you have to study. It is easily blown by the wind, then it is susceptible to water erosion and easily compacted. So this soil will get easily compacted and having a slight swelling and shrinkage and moderately difficult to till after rains. So this is a property of medium textured soil. So medium textured soil is are easily compacted, which is coarse textured soil, sandy soil, which is light fine textured soil, clay soil. So medium textured soil, or we can call it a silty soil, they are easily compacted. They are easily compacted. Which soil is easily compacted? Medium textured soil. Then clay. Next, clay soil. Clay soil is fine textured soil. This fine textured soil, which was a coarse textured soil, sandy soil. Then it absorb and retain more water. For sandy soil, they can't retain water. Water and nutrient holding capacity is very less. But clay soil absorb and retain more water. Become plastic and sticky when wet and hard and cohesive when dry. So they will become plastic means we are adding water to soil, like wetting the soil and molding into the shape, like by giving pressure we are making a shape, and when we release the pressure, like that shape, that it retains that shape will be like that only. So that property is known as plastic, and it is plastic because look in this picture, they are making a shape, and if we take our hand from that, that will be like that shape will be like that. You all know it's this property, and it is sticky when wet. It will be stick to our hand when wet, and hard and cohesive when dry. It will be very hard and cohesive when dry. And another property is that it is difficult to cultivate or till. So it is known as heavy soil. So at a when the soil is very wet, we can't use the machinery like a tractor and tiller, like that instruments in the soil, because it will destroy the structure, it will make the soil more compact, and it will damage the machinery. So they are known as heavy soil. No, this we call heavy soil because, not because it is heavy in their weight. Actually, clay soil is light in weight compared to sand soil of equal volume. But we call it this as heavy soil because they are difficult to cultivate or till. Then next is high water and nutrient holding capacity and poor aeration, very slow drainage unless cracked, and high to medium organic matter content. It can retain the organic matter also. So high to medium organic matter content, then medium to high swelling and shrinkage characteristics, then the resist water erosion and wind erosion and water erosion when aggregated. And good sealing property, retard leaching of nutrients and pollutant. So pollutants and nutrients will not go by leaching. Then it has good sealing property. We are using the soil for sealing and making some buildings, sealing the some thing. You know. So they also resist wind erosion because because of this property. Hmm? Okay. Then when aggregated, when they are made into large clots, they will resist water erosion. And clay soils are lighter in weight than sandy soil at equal volume. But we call clay soils as heavy soil and sandy soil as light soil because of the easiness, depending upon the easiness of tillage. And particle size of a mineral soil does not change readily. Then the particle size, this is an important point. Particle size of mineral soil does not change readily. Then you look at the picture: sand, silt, and clay. So sand is coarse texture, loam is medium texture, and clay is fine texture. Clay is somewhat compacted. Is it? Then points to remember: sand and silt particles consist of primary minerals such as quartz, feldspar, and mica. Clay particles are mainly secondary minerals such as kaolinite, illite, vermiculite, montmorillonite, chloride, hydrated oxides of iron and aluminium. Clay is a surface active fraction. That means it is a chemically active fraction of the soil with a high degree of chemical and physical activities, while relatively inert sand and silt fraction exhibit such activities to a less extent. Clay is known as a chemically active fraction, but sand and silt fractions do not have this chemical and physical activities. Is it? So these points I have taken from soil science treatise. You don't want to read, just remember these points. This I have already given in a box in the first lecture, I think, soil texture, so soil physics introduction part. Okay. Then another thing you have to learn is the specific surface of the soil. Specific surface of the soil. Then it is the surface area per unit mass of or per unit volume of the soil. So area divided by mass in a unit mass, like in 1 gram, for 1 gram of the soil, how much area is present? Or in 1 centimeter cube of the soil, how much centimeter cube of the soil, how much area is present? How much area is present? That is the specific surface of the soil. So, what is the unit? Area's unit is centimeter square, or we can say gram. So, centimeter square per gram, or centimeter square per centimeter cube. So, what is the trend like behavior of the specific surface means specific surface increases as the soil particle size decreases. So, when size decrease, if small sized particles will have a greater surface area compared to large sized particle. Okay. Then you can see coarse sand. Coarse sand is specifically is 45. While you can compare it with the clay. Clay, how much it is of 10 raised to 4 power. That means clay particles contain less, means smaller particles compared to sand, but its specific surface is more than sand. Is then you have to remember this also. Vermiculite have more specific surface among the clay mineral. Cavallinite has less. So just study this table. This is very important. Okay, if they ask about how much specific surface, you have to uh, know that. Like you can study the range only. Less than 100 it comes cavallinite, and like 700 to 900 range vermiculite will come, and 500 to 700 range montmorillonite. And this you can this is somewhat similar, right? But illite has less specific surface than chloride. That means you have to study this table. Which clay mineral have high specific surface? Answer is vermiculite. Then we can study the importance of specific surface. The greater the surface area, greater the soil's capacity for holding water fill. So, when surface area increases, it can hold water. Water holding capacity increases. Then greater surface area, greater the soil's capacity to retain nutrient and other chemical. Nutrient holding capacity also increases. Greater the surface area, greater the rate of release of plant nutrient from the weatherable mineral. So, whether minerals, when weather, they will release plant nutrients. Hmm. So, that is a thing. So they release plant nutrients from weatherable minerals easily when it has high specific area. The surface of mineral particles often carry both negative and some positive electromagnetic charges, so that the particle surface and water films between them tend to attract each other. And when size decreases, the negative charge and positive charge also increases, so they will with that charge they attract particles together. Then greater the surface area, greater the propensity of the soil particles to stick together in a coherent mass or as discrete aggregates. So when surface area increases, the stickiness or the formation of aggregates will be increased. Then microorganisms tend to grow and colonize a particular surface. So when there is more surface for the microorganisms, their growth will be more. So these all the properties are very means it is more in small sized particle. For example, we can say clay sized particle. So clay, for clay they have a good water holding capacity, good nutrient holding capacity. They release plant nutrients. They have a negative and some positive charge, and they stick together, or they form aggregates more easily when compared to sandy soil. And microorganism growth is also very high. So in this picture, you can see this is a larger size particle. This is a small size particle. As like a individual, when we cut this into many cubes, then this part also will contribute to the surface area, and like that. So both these contain same mass, that is 1.3 gram, but and volume is 512 millimeter cube. Okay, so when we cut this specific surface increase, that's why we call specific surface of small particles per unit mass will be greater than the specific surface of the big particle of same mass. Okay, that is the concept here. So that's all about our class, like soil texture. It's over. And one thing you have to remember, this is like this one, this part you have to remember, and which is light soil. Loamy soil contain equal properties of all the separates in equal proportion. Then easily compacted, medium textured soils are easily compacted. Then heavy soils are clay soil. Then clay's surface active fraction. Then vermiculite vermiculite has high specific area. The specific surface or specific area increases with the particle size decrease. Okay, so it's all about our class today, and I think everyone understood this concepts and these ideas. You don't want to read a fundamentals of soil science book and the soil science treatise if you hear this class. And for more videos, stay tuned, subscribe my channel, and give suggestions. And that's all about our class. Thank you very much.